So hello everyone, welcome back to my YouTube channel. So today we are going to solve this September daily challenge problem of Leetcode, which is 135 candy. So first of all we will read the problem statement as we always do. So there are n children standing in a line and each child is assigned a rating value given in an integer array ratings, okay? And you are giving candies to these children subjected to the following requirements. Each child must have at least one candy. Okay. And children with higher rating get more candies than their neighbors. Cool. Return the minimum number of candies you need to have distribute the candies to the children. Okay. So in this question we are given a rating array or vector in which the index represents the nth child, or you can say ith child, right? And the rating vector has values rating that each children has this much rating, like ith index has one rating, or uh, two rating, or zero rating, right? And we need to make sure that we will distribute the candies to the children, and also we'll make sure that the children with higher rating should get more candies than the neighbors, right? So how can we do that? So first of all, there are cases like, since we are concerned about that the children with higher rating get more candies than their neighbors, right? So we'll we will can't sort this array, right? Because it will and you can say uh, the neighbors gets affected, right? If in this array this child has this and this neighbor, if I'll distribute, or sorry, if I'll sort this array, then it will be 0 0 1 2. Now this children has different neighbors, 1 and 2 will not be the part of this neighbor, but in this case we 2 is the neighbor of this child, right? So we can't sort this array, so sorting approach will go into vain. So we will try to do another approach, right? So there are two cases, right? uh, Not two cases exactly, we have three cases. First is, either our rating array will be in, you can say, increasing order, right? So in that case, what I can do is, since we need to make sure that every children must get at least one candy, right? So we will do one candy to this. After that we'll move to second index, or first index, sorry, if we are considering zero based indexing. So this children has rating greater than this neighbor, right? So we can do is, we will give two candies, right? After that, if we go over this index or this children, we will this children has more rating than this, than the neighbor of, than his neighbor, right? So it will get three candies, right? So we can simply say 3 plus 6 candies we need to distribute, right? After that, one case is that our array is in sorted in the decreasing order. So 3 2 1, let's suppose this is the rating of the three children, right? So if we distribute 1 to this children, now when we move to the second index, our I ith children has rating 2, and it is less than this uh, neighbor index, right? But the greater than this neighbor, right? So we will make sure that uh, we will increase the candies, number of candies. Initially it was one, because we need to distribute each children with at least one candy. So initially it was one, but since this rating is greater than the neighbor of this neighbor of his, so we will increment this, so it will 2. But now the condition fails, because this children has higher rating than this, but still we are giving him less candies than this children, right? So here are, this approach will fall, like fails, and if we are giving two candies to this, then we need to make sure that we will give them three candies, right? After that we'll move to other index, or you can move forward to the next children, and then we'll give him initially we are given a one candies to each children, so we are good to go. We will not give more candies to this children, since it is not greater than it any of the neighbors, right? So this is the you can say the distribution of the candies, right? In this answer we will also get 6. So if you think that if we try to do this example with last index, right? So we will give one candy. After that we'll move forward to the next index. We are at this index, right? So this children has rating greater than this, right? So we will make sure that we will give him extra candies which this children have. So if it is having one candy, so we will give him one extra candy too. After that we will move forward to the other index. We are at this index, and we since our rating since this children has rating greater than its neighbor, so we will make sure that we will give him extra candy, one extra candy than his neighbor. So this is the scenario, right? So we will 6, like now we can also have a case where the you can say the rating will be like this: amount to first increasing 5 3 1 4 6, right? So this can be also the test case, right? So in this case what we can do is, if we start from this index, right, we'll give each children initially one candy, right? And then we start from this index. This index has greater than the neighbor index, right? Since this is this candy, if we try to if we try to only look at the uh, left index, left neighbor, right? Sorry. So if we try to find the neighbor in the left for this index, it is not having any neighbor in the left, so we will move forward. We'll start from this index, right? We'll check either this has a left neighbor. Yes, it has a left neighbor, and the rating of this is less than this 5, right? So what we can do is we will ignore that. We'll move forward. We'll check this and this children has left neighbor. Yes, and if the rating of this children has greater than the left neighbor, then we'll increase the number of candy. If this is not the case, we'll move forward to the other children. Then we will have 4 rating at this index. So we'll check if we have a left neighbor. Yes, we have a left neighbor, and the rating of the left neighbor is less than the current children, right? So we'll make sure that we will increment this to 2. Okay, after that we'll move to the this index, and this index also has a rating greater than this, so we will make sure that we will give him extra candies than the neighbor. So we will give him 2 extra candies, so that it will the it will satisfy the condition that the neighbor of the children with higher rating get more candies than the neighbors. So if we give him only initially it was 1, if we will give him only one extra candy, then it will be 2, and the condition fails because the children with higher rating has equal candies which with the neighbors, right? So we will make sure that we will give him 3 candies two extra candies, which will result into 3. So the answer would be 1 plus 1 plus 1 plus 1 3, 3 plus 3 6 8. But now we will also have to iterate from the right or the last uh, index. So 5 3 1 4 6, right? If we start from this index, initially we will give one index to each one candies to each children. Sorry, wait a second. Initially we will give one candies to each children, right? After that we will iterate from last index. 6 doesn't have, when we are moving from the last index, we will try to find the right neighbor. This index doesn't have any right neighbor, so we'll start from this only, because at every in every test case the last index doesn't have right neighbor, and when we are doing from the first index, we will know that the first index or the zeroth index doesn't have left neighbor. So we will in this case we will try to start from this, and in this case when we are iterating from the last index, we will try to start from this index and minus 2 index, right? We will check either this children has a right neighbor. If yes, then we will check either the rating of this children is greater than the neighbor. No, this is not the case. We will move forward, right? We will be having one rating at this index and it is less than the right neighbor rating, so we will move forward. When we will be having 3 rating and the right neighbor has 1 rating which is greater than the, so the rating of these children has greater than the neighbor rating, right? So we will try to increment, or we will try to give him extra one candy, right? After that we will be having a, we will be at index 0 and the rating of this is 5, which is greater than the right neighbor. So we will try to give him two more extra candies, which is 3. So it will resulting into 1 3 2 1 3 2 3 6 8, this. So but if we try to find the optimal solution, what we can do is we will pick up the maximum from this. So we'll pick this 3. At this index we will pick 2. At this index the maximum is 1. At this index we will have 2. At this index we will have 3. So this is the final answer, 3 to 1, which is 11. This is the answer for this solution. Why I am not considering this only or this only? Because if we check, initially it was 5, right? When we are traversing from this, we are at 5 index, right? This 5 and this 3, if we compare that rating, 5 is greater than 3, but still we are giving the equal number of candies, which is not satisfying the condition. We will have to give him the we will have to give extra candies to the children which is having greater rating than his neighbor, right? So we will consider the maximum of these two when we are iterating from left and when we are iterating from right. We will have to, keep the maximum and then we will return the summation, right? So how we can code this? I hope the explanation justifies the code. Let me first, we will declare a vector of int left and the size. Let me declare the n variable, which is the size of the this ratings vector, right? After that, vector in left, the size of this left must be 1 and n, and the all initially all the elements of this left will be 1. Also for right we will be having n1. After that, what we need to do is we will first do from left to right iteration, and we will also make a answer vector which is of a size n. When we are moving from left to right, we need to make sure that the left neighbor has the rating lesser than the current children, right? So since if we start from 0th index, there is no such left neighbor, so we will start from I less than n I plus plus. What we are going to do is, if ratings of I is greater than ratings of I minus 1, that is left, right, left neighbor. So if this is the case, what we will do, we will simply left of I will be increased by 1. So whatever we have in the left neighbor, we will increment the number of candies by 1, right? After that, we will be traversing from right to left iteration for int. We have not declared int I equal, since when we are traversing from right to left, so we need to make sure that the right neighbor have a rating lesser than the current children, right? So we will start from n minus 2 with index, and I will greater than equal to 0 I plus plus I minus minus. And if rating of I is greater than rating of I plus 1, which is right neighbor, then we will make sure that the right of I will be 1 extra than the right neighbor, I plus 1th neighbor, right? After that, what we need to do is we will start from 0th index, and be we will go up to n, and in answer vector, answer of I, we will be having maximum of left of I comma right of I, and after that we will return answer of I. So we will declare result variable, since we need to do a summation over here, resultant plus equal answer of I, and we need to return result over here. Let me check this. Yeah, so it is working fine. Now we will submit this solution. So yeah, it is perfectly running all the test cases success. So I hope this explanation and the code justifies, and if you find this video helpful, please make sure that you will like this video and subscribe to my channel, so that I will keep posting daily Leetcode challenge problems. Thank you for watching.